When I went to university, I wanted to keep all of my options open, so I studied a combined arts and science degree doing philosophy, statistics and genetics. While doing all of those three things together, I started to see ways in which they were connected and that I could actually combine them into a single career path. When I came to starting a PhD, it was right around the time that the Human Genome Project was finishing, and we were starting to develop new technologies that came out of that to study genomics of plants and animals and microbes. So we started using genome sequencing to study the transmission of typhoid in Kathmandu in Nepal. And what we found was that a lot of the assumptions that we'd made previously about typhoid being transmitted from person to person were actually incorrect. Many cases where individuals in the same household who had typhoid fever around the same time were actually infected with completely different strains of the bacteria. So they were being infected from the water that they were drinking and the environment they were exposed to. So back here in Australia, we're not so concerned with typhoid and dysentery, but what we're really concerned with are infections acquired in hospitals. So we're really interested in using the new genomic approaches to understand how infections are transmitted in hospital. So the L'Oreal Fellowship will allow us to look at whether patients coming into the ICU are actually carrying drug-resistant bacteria when they arrive, and the impact that that has on the development of infections during their hospital stay. It's a very exciting time to be a computational biologist, as the flood of data coming in from all over the world is giving us a tremendous wealth of resources, enabling us to look at the spread of infectious diseases all over the world. And that's particularly important at the moment because the spread of antibiotic-resistant bacteria are really threatening our ability to treat infections.